We think, so let's say group G acts on a set X. And we have this relation idea here that basically for any AB inside the set on which the group acts, we have A is in a relation like this with B. And that is equivalent. That happens if and only if. So I can either use this or I can say if and only if. If and only if. For any A inside the set X, there exists something in the group G such that for any elements A, B in the set, we have GA equals B. So we can find an element from G that if it acts on this element from X, it will give that other element in X. Then A and B are in relation. And for relation, we need reflexivity, symmetry, transitivity. Well, first of all, reflexivity. So we want some GA that gives A itself. Reflexivity means that A is element A from X is in relation with itself. Well, yes, because there exists such a G. That G will be the identity element. So that's fine. So that's reflexivity. Symmetry, well, GA and let's have some element. Let's say we want to say that if A is with B, in relation B is with A. So GA is in with B. Well, we can also say, multiply from the left by the inverse of G. So there exists a G such that G acting on A gives B, but there also exists a G inverse, which must be inside the group, which from the left acts on B, that gives A. So we have that, and symmetry is probably the trickier one here. The transitivity is the trickier one here. So let's say for any ABC, so we add one more element from the transitivity, we need 3 elements here, inside the set X, on which the group G acts. We can have GH, and transitivity, what it says is, if one thing acts on another and that second thing acts on a third, we also have that the two things will lead from the first right to the third. And we can show that here. I mean, if this is one element from the group, so we will take not only G from G, but let's also say for any ABC in X, there exists G and H in the group G, such that we can do the following. For GH equals B, let's say then H, another element from the group, takes that B and puts it into C, where A, B, and C are elements of actually the set on which the group acts. And then we have, actually, we can take the GH together like this and act it on A, but see that it actually has the transitivity because we can reorganize the associativity parentheses. There's some fundamental properties with group actions. So we have this, but I should, the other order, should be careful about this. But GA we know is B, so that's like H of B. But HB is C. So yes, we do get directly from A to C. So transitivity is there as well.